Hello guys, welcome to our YouTube channel. Today we going to discuss about semiconductor materials. So semiconductor materials are a class of materials where electrical conductivity lies between the conductor and insulator. So how we can understand this thing? Like if we want to understand this thing, we can understand by the energy band diagram. In metals, the energy band diagram, the valence band and conduction band are overlapped. But in semiconductor, those band gap having little distance, which is less than 3 electron volt. In the case of insulator, it is higher than 3 electron volt. So if you see in case of metal, there is no gap. In semiconductor, gap is small. In case of insulator, it is a big. Okay, so we can understand that with energy band graph, how the conductivity varies. In semiconductor, we can say there is two types of semiconductor. One is intrinsic semiconductor, other is extrinsic semiconductor. How we term as intrinsic? These are the semiconductor which are pure form of material. In extrinsic semiconductor, we have foreign element doped with pure. Why we are doing doping here? To improve the electrical conductivity. In extrinsic semiconductor also, there are two types of semiconductor. There are two types of semiconductor. One is N type, second is P type. N type semiconductor are the class of negative doping, and P type is positive doping. Here the electrons are dominate. Here hole are dominate. So let us understand this P type or N type concept with the help of one example. So I am taking basic semiconductor material as a silicon, and we will see how silicon we can make N type and P type. When silicon is doped with silicon having +4 valency. When silicon is doped with +5 valence element, e.g. like nitrogen, phosphorus, arsenic, bismuth, so it will become N type. How? Because of this extra electron. When silicon with same 4 valency doped with +3 valence element like aluminum, gallium, indium, so it will become 1 electron deficit. So there is one extra vacancy created, which term as a hole, which is positively charged carrier. So it is called p-type semiconductor. So what is now, if you can understand by layman definition of the n-type p-type, so here is the electrons are majority charge carrier, here is the hole or majority charge carrier. So if we talk about the applications of semiconductor, there are a huge and wide range of applications of semiconductor materials. So human race started with Stone Age, then Bronze Age, Iron Age, now it is a Silicon Age. All our electronics gadget devices are made with silicon wafer. Without silicon, we can't dream about any electronics device. So now we see the specific examples where the semiconductor used in our daily life. So these are used in making transistors, diodes and integrated circuit, IC circuits. Semiconductors such as silicon have ability to control the electricity. I told you how we can control the electricity, flow of electricity, by the making charge carrier type, n-type, p-type. Okay. So this silicon, because of this property, silicon become very fascinating elements, and it is also earth abundant. So our all computer chips, other electronic components like smart watches or our screens, LEDs, all having semiconductor materials. So in summary, we can see this is the general outline of semiconductor materials and their types. If you have any doubts, please write in the comment section. We will resolve it. Thank you for the listening, watching.